We're going to solve some problems here involving right triangles and the Pythagorean theorem. So as a start, let's see what the theorem says. It says if we have a right triangle, now a right triangle is a triangle that has a 90-degree angle in it, and maybe we have this leg of length A, this leg of length B, and this hypotenuse of length C. The theorem says A squared plus B squared equals C squared. What it means here is that if you take the measure here, square it, add, take that length here, square it, you will get the square of the hypotenuse. So let's work a bunch of problems. So what we want to do is we want to find the length of the hypotenuse in this right triangle. All right, we're given that it's a right triangle, so that's a right angle right there. So you probably want a calculator for this, because what we're going to do is use the Pythagorean theorem, and the numbers could get a little bit high. So the theorem, tells us that a squared plus b squared equals c squared, where c is the hypotenuse. A is one of the legs, so for us it could either be the 7 or the 24, and b is the other leg. So how about if we write it like this? Say we have 7 squared, so I'll let a be this vertical leg, and b will be the 24. So plus 24 squared, that's equal to c squared. Now, 7 squared we know is 49, plus 24 squared, 576, that's equal to c squared. And if we add these two numbers together, we get, adding these together, we'll get 625, and that's equal to c squared. But it's not c squared that we're looking for c. So we have, I'll write it up here again, 625 is c squared. Why don't we square root each side? And because c is a positive number, we're just going to get c on this side. And this turns out to be 25. So there we go. So this turns out to be a right triangle of lengths 7, 24, and 25. Now here in problem 2, we're given a right triangle. All these are right triangles in this section. So we're given this right triangle with this length here, this leg of 16 units. We don't know this length, but we do know the hypotenuse. So we can still use Pythagorean theorem. Let's write it here. We'll get a squared plus b squared equals c squared. And in this case, we could write this one as a. This will be our b. So we will have 16 squared plus b squared equals, and c is the hypotenuse, and that's 34 in our case. So we're going to get 34 squared. So 16 squared is 256, plus b squared equals 34 squared is 1156. And then we're going to subtract this 256. And so that'll give us that b squared is equal to 1156 minus 256 is a 900. And if we take square roots, now the square root of b squared is b because b is positive, and square root of 900 is 30. So there we go. Now this problem number 3 is very much like number 2. Number 2, we were missing a leg, and over here we're missing a leg. So we're going to write it pretty much the same way. This leg over here is A, whereas in this one back here, it was B. So we're going to write a squared plus b squared equals c squared. Write our formula first and then just substitute in. So we'll get a squared plus, let's keep the units on this time, 4 centimeters squared equals 18 centimeters squared. This will give us a squared plus 16 centimeters squared plus, now 18 squared is, this is an equal sign here. This is equal to 324 centimeters squared. Then we are going to subtract those 16 square centimeters. So we'll get a squared equals, now 324 minus 16 is 308 square centimeters. And taking square roots, we'll get the square root of a squared is the square root of 308 centimeters squared. And on the left side, because a is positive, we'll get a equals. Now, for the square root of 308 on my calculator, I'm showing about 17.5499 ... And then the square root of centimeters squared is just centimeters. And what we're going to do is just round off here. Why don't we round off to the nearest, well, let's round off to the nearest hundredth. So how about a equals 17.5, because that's a 9, I'm going to round up 55 centimeters. And in problem 4, we're given a right triangle with legs A and B and hypotenuse C. And what we're supposed to do is find the missing side. So we're given, well, we're not given A, but we are given B is 32 and C is 36. So let's write our quadratic formula. How about a squared plus b squared equals c squared? We'll get a squared plus 32 squared equals 36 squared. You know what? How about if we try it like this? Let's subtract 32 squared. So we'll get a squared equals 36 squared minus 32 squared, and then do it all at once on the calculator. We'll get a squared equals, now on the calculator I'm typing in this, 36 squared minus 32 squared. So we're getting a squared equals 272, taking square roots of both sides. Square root of a squared is a, because a is positive, and the square root of 272, I'm getting 16.492 ... But if we round to the nearest tenth, we're going to say here that a is equal to 16.5. So here in problem number 5, we are given A, we're given B, and we want to find C. So let's write our quadratic formula. A squared plus b squared equals c squared. Substituting in, we'll get 7 squared plus 9 squared equals c squared. About 49 plus 81 equals c squared. 130 is equal to c squared, and if we take square roots, we are going to get, my calculator showing 11.4017 ... That's equal to c. So if we round to, now the problem tells us to round to the thousandths. So that's 3 decimal places. So that's going to be 1, 2, 3. That's bigger than 5. So I'm going to round that up. So how about C equals 11.402? See what we have in number 6 now. These problems are starting to look pretty much all the same, aren't they? How about if we go with, we've got a right triangle here, so a squared plus b squared equals c squared. And if we take this as a, we could take this as a, it doesn't matter, right? How about this as a? So we'll get 11 squared plus 9 squared equals c squared. 121 plus 81 is c squared. Add these two together, we get 202. So 202 is equal to c squared. Taking square roots, we're going to get, now I get 14.2126 ... That's equal to c. And I think the book is asking us to round this off to the nearest tenth. So looking over here, that's less than 5. So how about if we write this as 14.2 and we'll drop the rest of those digits. We have an application problem here in number 7. This is a slow pitch baseball diamond, and it says that the book tells us it's actually a square. So if this is 62 feet here, this is 62 feet. And from first to second, right here, this is a right angle. So look what we've got. Leg, leg, hypotenuse. So we've got a right triangle here. We're trying to find the distance from home to second. So we'll use the Pythagorean theorem. So we will get that a squared plus b squared equals c squared. And how about for a and b? We use 62 and 62. We will get 62 squared plus 62 squared equals c squared. 62 squared is 38. 44 plus another 38. 44, that's equal to c squared. Add these two together, we get 7688 equals c squared. We'll take square roots. 7 square root of that equals square root of c squared. And I got 87.68 dot dot dot. That's equal to square root of c squared, because c is positive, is c. And what we're going to do is round to the nearest tenth. So let's round here. This number here is bigger than 5, so we'll round up. So how about c is equal to 87.7. Now this is all feet. So the distance now from home to second is 87.7 feet, approximately. So in number 8, we've got this loading ramp where the height here is 9 feet. The distance out here to the end of the ramp is 15 feet. We want to know exactly how long, or what we want to know is how long is this ramp. So I guess we're going to assume this is at a right angle, and then using the Pythagorean theorem, a squared plus b squared equals c squared. It'll give us 9 squared plus 15 squared equals c squared. About 81 plus 225 equals c squared. Adding these two numbers together, we get 306 is equal to c squared. Square roots. And I'm getting 17.49 dot 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 equals c. So how about c equaling 17.5, because we're asked to round to the nearest tenth. So we're going to claim now that the length of that ramp is 17.5 feet. So in this problem, we have a roof truss, and here's the rafters. The rafters are, in this problem, 24 feet long. And we've got a height here of 9.5 feet, and this is the base of the truss. And we're going to assume it's at a right angle here. So if this is the right angle, we can get this length right here using the Pythagorean theorem. So if we say this is b, we're going to have a squared plus b squared equals c squared. So 9.5 squared plus b squared equals 24.0 squared. This will give us 90.25 plus b squared is equal to, now this is 576. Let's subtract that 90.25 from both sides. Doing so gives us b squared equals, now 576 minus 90.25, I'm getting as 487. Let me try that again. I'm really getting 485.75. Take square roots. And I'm getting that b is equal to 22.039 dot dot dot. But now what they're actually asking us for is the length of the base of the truss. They're asking us, back up here at the picture, they're asking us for this entire length right here. We found half of it, right? We just found this, but we want the entire length, so we'll take this and double it. So what we're looking for is 2 times b, and if we multiply this by 2, we'll get 44 point, now we need to round off. So we're given that this figure here is a picture of a roof truss. And what we're told is that the rafters right here and here are 24 feet long, and that includes a 1.5 foot overhang. So this part right here, here's the overhang, and we're told that okay, let's get that here. This distance right here is 1.5 feet. So that means that from here to here, right, this distance right here, that hypotenuse of that right triangle is going to be 24.0 feet minus 1.5 feet, which is 22.5 feet. And what we're trying to do is find the length of this base right here. So I think here's what we could do. We know that this is a right triangle here. We have one side. We have this hypotenuse. We can get this side right here with the Pythagorean theorem. So here we go. We'll get a squared plus b squared equals c squared. So how about 9.5 squared plus b squared, that's what we're looking for, equals 22.5 squared. Right, we don't want to be squaring the 24 because that's the entire length of the rafter. The hypotenuse only goes from here to here, so that's at 24, the entire minus the 1.5. Now, 9.5 squared turns out to be 90.25, right, square feet, plus b squared equals, and 22.5 squared is 506.25 square feet. Now, let's subtract that 90.25. That'll give us b squared equals 416. We'll take square roots. And square root of b squared is b because b is positive. And now here's what I got. I got 20.396 dot dot dot. Oh, not b squared, just b. All right, so b is equal to 20.39 and so on. But now what we're asked for, see what we just got here is b. We are asked for the length of that truss right here, the base. What's the length of the base? We're just given half of it. So this number that we just computed, that b, that represents half. So what we're looking for is twice that. We want 2b because we want the entire length, so we want to multiply this by 2. And when I do that, I'm getting 40.78, and we want to round off to the nearest tenth. So why don't we say this is 40.8 feet. We've got a rectangular solid here. In my problem, it's a toolbox. And what we're going to do is we're given a formula that finds the length of a diagonal. Now, a diagonal might be, say, from this top up here down to this bottom down here. That would be a diagonal. And we're given a formula for that. We're given this formula here. The d is equal, d for the length of the diagonal is equal to this. L squared plus W squared plus H squared, where L is the length of this box, W is the width, H is the height. Now, suppose that we're given that the length there is 16, and the width is 8, and the height is 6. Let's find the length of this diagonal then. So we're going to get, now just making those substitutions, we'll get D equals the square root of 16 squared plus 8 squared plus 6 squared. D is equal to, when I take the square root on my calculator, I'm getting 18.86 dot dot dot. And how about if we round off to the nearest hundredth? So actually I'm getting 867 and so on. So if I round off to the nearest hundredth, I'm going to get that diagonal is 18.8 tenths, hundredths. We'll round off to here. 87, probably inches. So let's read through this here. Here's what we have. The hypotenuse of a right triangle. So we've got a right triangle. First up, let's just draw a right triangle. So here's a right triangle. Just any right triangle will do. And we're given that the hypotenuse is 19 centimeters. Then we're given that one leg is twice the other. Okay, one leg is twice as long as the other. So what if we let this leg be x, because we don't know what it is? That would mean that this one here, this one down here, is twice this. So twice x is 2x. So now, using the Pythagorean theorem, we will have x squared plus that 2x squared equals 19 squared. Okay, let's just be careful here. We have to be careful what we write. We do not want to be writing this 2x squared, because in this case only the x is being squared, not the 2. We want x, double it is 2x, we want that 2x to be squared. So this will give us x squared plus, now squaring 2x, we'll get 4x squared equals 19 squared, which is 361. And then we've got x squared and 4x squared. There's 5x squareds there. That's equal to 361. How about if we divide by 5? And what I'm going to do this up here. We'll get x squared is 361 divided by 5. Let's take square roots. Square root of x squared equals square root of 361 divided by 5. So we'll get x equals, now on my calculator I'm going to put this. I'm going to type in square root, or I press the square root sign, I get a parentheses. And I'm going to type 361 divide by 5. And that gives me that x is equal to, all right, I'm going to round this off. It says, well, I'm getting this, 8.49 dot, dot, dot. I'm going to round this off to 8.5. So now here's the picture. I'll do it up here. Here's what we're looking at. We're looking at this picture here where x, now what is x? Let's go back here. What is x? X is, say, one of the legs. So maybe I can make this one up here 8.5. Now this one down here would be twice 8.5, and that's equal to 17. And this one we know is 19. So the perimeter is the length around. It's this plus this plus this. So the perimeter is going to be 8.5 plus 17 plus 19. When I add all those up, I'm getting 44.5, and I guess this is all in centimeters. So there we go.